All right, so for the second part of our Chapter 9 review, let's take a look at some absolute value stuff. Remember, the absolute value is the distance a number is away from 0. And since we are measuring a distance, that means an absolute value can never be negative. So it basically takes the negative off of any number. So what number could x be such that I take the absolute value or take the negative off to get 51? I claim that x, or the number inside of this absolute value, could equal either 51 or negative 51. If you notice, I took the number out of the absolute value and set it equal to the positive and the negative version of that answer to get two different answers. Well, if you want to check yourself, ask yourself, what is the absolute value of 51? It is, in fact, 51, so that answer checks out. And what is the absolute value of negative 51? It is positive 51, because that's what absolute values do. They measure a distance, so the answer is always positive. So in other words, this one checks out. So my answer is either plus or minus 51 for number 14. For number 15, before we analyze the absolute value, you need to get it by itself. In other words, you need to get rid of all of the other guys on the same side of the equal sign that are not inside the absolute value. So this 2 needs to move. Right now it says 2 times the absolute value of y, so the opposite of times would be divide. Let's divide both sides by 2, and we get the absolute value of y equals 10 divided by 2 is 5. So that means that y itself could equal either plus or minus 5, just like we did on 14. On 16, we're doing the same kind of idea, but first we need to get rid of the 7 and the 3 before we can analyze. So let's move that 7 away by subtracting. That means I get 3 times the absolute value of g equals 6 minus 7, well, that's negative 1. And then if I divide both sides by 3 to get the g by itself, I have the absolute value of g equals negative 1/3. I think this is a big problem because g, what could g be so that the absolute value of it is 1/3? Like if g equaled 1/3, the absolute value would equal positive 1/3, not negative. Well, if g equaled negative 1/3, the absolute value of it would be positive and not negative. So therefore, I think we have a big issue. I think that this is a no solution. Again, it is a no solution because there is no such number that I could put in the absolute value and get negative 1/3 for the answer. On number 17, take a look. There's nothing outside the absolute value, so we are already ready to analyze it. Very similarly to how we analyzed number 14. On 14, you ask yourself, what number could I take the absolute value of and get this? Now I'm asking, what number could I take the absolute value of and get this? Well, I think that all of the stuff in here, all of this, could either be 11 or negative 11, because the absolute value of 11 would be true. The absolute value of negative 11 would also work. So that means I need to take the numbers out of the absolute value, m plus 2 in this case, and I need to set them equal to either the positive or the negative version of their answer. Very similarly to how I did it up here. On the left, I see that m plus 2 equals 11, so if I minus 2 on both sides, I have m equals 9. And on the right, if I minus 2 on both sides, since this is already a negative 11, I have m equals negative 13. So for this one, I have two separate answers, not plus or minus the same version of the same number. We're going to do the same thing on 18. Take this stuff out of the absolute value and equal it to the positive of its answer and to the negative of its answer. And then we're ready to solve. If I add 3 to both sides, then I have 2x equals 20. And then if I divide by 2, I have x equals 10 for one of my answers. If I add 3 to both sides over here, I have 2x equals negative 14. And then if I divide by 2, I have x equals negative 7 as one of my answers. If you would like to check them, plug it in. Is 10 times 2 minus 3? Give me a number whose absolute value is 17. And is negative 7 times 2 minus 3? Give me a number whose absolute value is 17. They both will work. Finally, the last one is the same situation. I have 5x minus 1 equals positive 4, and I have 5x minus 1 equals negative 4. And then I'm ready to solve. On the right, on the left, I'll add 1 to both, so I have 5x equals 5. Then if I divide by 5, I have x equals 1 for one answer. And then on the right, if I add 1 to both, I have 5x equals negative 3. Dividing by 5 gives me a fraction, x equals negative 3/5. For the next piece, we're working with a piecewise function. Before we graph the piecewise function, let's just go ahead and attack these problems and see what we get when we plug in these values. For number 20, it says if you plug in, remember, this is usually f of x, and f of x is equal to y. So whatever is inside the parenthesis represents the x, and whatever that whole thing equals is my y. So this number, since it's inside the parenthesis, equals my x. So if the x is negative 4, I'm basically asking what is the y. I apologize that my xy axes didn't show up very well on this graph. Let me just make them a little bit darker for us. Here is the y-axis, and here is the x-axis, so we can read this graph a little bit easier. All right, here we go. So if my x is negative 4, let's go on my x-axis negative 4. 1, 2, 3, 4. Where is my graph? Do I have to go up or down to find my graph? No, I'm already on it, so that means that my y value must be 0. Let's try it again. What about if my x value is 5? I go from the origin over 5. 1, 2, 3, 4, 5. Here's where x is 5. What is the y value of my graph? Well, I have to travel up to get to my graph. I have to travel up 1, 2, 3, so my y value is 3. All right, here I'm asking a different question. F of x equals 9, so that's really telling you your y is 9. My y value, remember this value that I put over here is my y value, so I'm telling you your y value is 9. What is the x value? So on your y-axis, go to 9. On my y-axis, I'm going to go to 9, which is here. Now, where is your x at? 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's my y value. Where is your x at? It's over 1, 2, 3. So my x value would have to be 3. Similarly, on number 23, your y value is 0. So I'm here, what's your x value? I claim there are two x values where the y value is 0, both here and here. So I'm going to put two answers, 0 and negative 4. Again, my y value is 0, so how far do you travel left or right to get to your x, or to get to your graph? Either here or negative 4 here. Finally, my y value is 1, so what's your x? Go up 1. Now, where do you have to go to get to your graph? Ooh, there's 3 answers here. 1, negative 1, or this one in the middle. 1, negative 1, or, I guess you could say, and, what is that, 4.5 maybe? Negative 4.5? Is that right? Let me count that again. 1, 2, 3, 3.5. Negative 3.5. Again, all 3 of these are the correct answer for number 24, and the reason being is I go up 1. My y value is 1, so I could go here to find my graph, here to find my graph, or here to find my graph. There are 3 points on the graph where my y value is 1. Now, let's write the piecewise function for this graph. Let's start with this piece. This piece we'll put in red here. Let's first talk about the slope of that piece, my M, my slope. If I start at, say, a point, say, right here, and I go to this point here, it looks like I go up 2 over 1. Will that work? Up 2 over 1, up 2 over 1. I think my slope is 2 over 1 or 2. Let's talk about the y-intercept, the B, okay? If this line were to continue up 2 over 1, up 2 over 1, I'd be right here where my B is 8. So my B is 8. That means I can write this equation as y equals my mx plus b, and then let's write those domain restrictions. If x is in between, you notice that I'm using the underline here because both of these are technically closed dots. We have no holes or open dots on our graph. So I'm just going to use this the entire time, which is awesome. What is the leftmost x value of my graph? Well, that would be -5. And what is the rightmost value of this red graph? That would be x is -2. So there is the full, complete version, including domain restrictions for just this piece. Now let's talk about this piece. Well, that piece would definitely be a parabola. This guy right here, let's make him, I don't know, purple. Okay, this guy is what I'm talking about, is a parabola. So we're going to use vertex form to graph him. That means I need to know what is the A. Is it positive or negative? It is definitely positive because it opens up. And what is your vertex? Well, it looks like my vertex right here is 0, 0. So that means the formula would be A, which is positive, times x minus this sign changes. Well, it's 0, so it doesn't even change, and then plus 0. If you'd like, you can write it like this, or you can simplify that. Doesn't that just simplify to y equals x squared? Because all the zeros kind of cancel each other out. So y equals x squared will be the parabola if x is in between. Again, I'm using underlines because this is a closed dot, this is a closed dot. My leftmost value of this parabola for my x value is -2. And my rightmost point for this parabola, I'm talking x values here, is, let's see, 1, 2, 3. For the x value, goes over to 3. So I'm going to put a 3 there. All right. Last but not least is our last linear line. I have this guy right here. Let's talk about him. He's a line, so he has a M and a B. Let's talk about a slope. Here, if I start here, I have to go up 1, 2, 3 over 1. So it looks like maybe -3 over 1, or I would say 3 over -1, because I have to go up 3, 1, 2, 3, but left 1. So -3 over 1 for my M there. And my B, where does this guy cross the y-axis? Well, he doesn't right now, but think about where he would. It'd be somewhere up here. And if you think about it, for every line I go over, I have to go up 3. So I went up 1, 2, 3 to go over 1. 1, 2, 3 to go over 1. So to go over 1, I'd have to be up another 3. To go over 1, I'd have to be up another 3. And then to go another 1, I'd be up another 3. So that's 1, 2, 3 threes, or up 9 total from where we already are. Well, we are already at our y value of 10, so I have to go up another 9. I'm sorry, we're already at our y value of 9, so to go up another 9 would be 18. Again, I have to go up 3 to go over to be on this line. And then I have to go up another 3 to be over on this line. And then I have to go up another 3 to be over finally on our y-intercept. So that's 3 plus 3 plus 3. I'm going to be traveling up from where I already am. And this value where I already am is at y is 9. So up another 9 would be y is 18 for my b value. So to write this equation, I have y equals my b, or sorry, my m, -3x plus b, which is 18, if my x is in between what 2 points? Well, my leftmost point there is 3, and my rightmost point is 5. Again, I got those blue numbers by doing my leftmost point of this green graph is at x equals 3, and my rightmost point is at x equals 5.